Hello everyone, welcome to practical number 1. The name of the practical is Microprocessor Simulator 8085. So as you know, in our recent lecture where we studied this diagram in which we had all these registers including accumulator, status register, register B, C, and all the other registers. We had this ALU, arithmetic logic unit, and we saw what's the function of the ALU and the internal architecture of a generic microprocessor. So in this practical you will learn how to utilize these registers to do various operations in the microprocessor. So as you will go through your practical, you can see that this practical defines every section in the software in details. This software has this name of the software is Microprocessor Simulator 8085 or 8085 Simulator. So this software has various sections. They're called editor window, workspace window, register sections, and like that. If I open up this software, you can see the various sections are here, and here is the actual software. It looks like this one, and so basically this simulates how your register will work, your registers will work, and all the other things which are included in the microprocessor will work before you actually implement in the hardware. So to make an example, I'll simply start with a simple program which we have also seen in our class. The program does the addition, and we already have an idea how to do the addition with the microprocessors. I'll write the same program in here, and we will see what are the changes that we can see in this simulator. So just to recall, we have this accumulator here. Any changes in the accumulator register will be shown in here. We have register B, register C, register D, E, HL. Okay, so these are the same registers as we have seen in this diagram. And here we have the assembler, and in the assembler we will write the program. So let's say I want to add 02 and 03. I have two numbers, so I'll write a program. The program goes like this: MVI, which is move immediate, register A, comma, and you have to give the space, and then you write 02, just 2. Okay, and hit enter. Then I have to give second word, so MVI. I'll be putting the second number in the register B, comma, space 3. Okay, so I'll be adding 2 and 3. So to add these two numbers, I will be using the instruction ADD add space B. So as we already know that one of the numbers will already be in the accumulator, so add B means the accumulator and the contents of the accumulator will be added with will be added to the component to the contents of register B. So by this instruction, by the time we reach this instruction, our addition will be complete, and the last instruction will be HLT, which is the halt instruction, and it means stop the program. So we have this very small program in here, and the first thing we want to do, if you want to run the program in the microprocessor, first we need to assemble it. So here is the assemble button. I'll click it, and when I click the assemble, you can see that I have various mnemonics in here. So mnemonics, that means the all the assembly language instructions, these are also called mnemonics. So MVI A comma 02 and MVI B, and we have the add instruction, then we have the halt instruction. If you have any error in the program, it will be shown in here, like so you have to be very careful with the program writing. Like if I remove the space between the comma and 2, just here, if I hit back and then hit assemble, you can see it says error at line number 1. So that removal of space, it just causes the error in the program, so it will not run. So you have to put space between and the comma and the number with every instruction. So again I have put the space. Now assemble again, you can see that you have no error. Okay, so one thing I would want to clear here is this thing. It's called the hex code, or the machine code for every instruction. We will be discussing this one in the class in details, but by now we can just keep in mind that every instruction, and that every assembly language instruction like MVI, it has a equivalent hex code which actually goes and runs inside the microprocessor. So MVI A is equivalent to 3E, MVI B is equal to 06, add B is equal to 80, and HLT that's equal to 76. Okay, so this instruction 3E will be followed by this number which is going to be added 02 here, and the instruction MVIB that's equivalent to 06, and the actual number will be here 03. Okay, so once we have successfully assembled the program, we will now go at this part of the software, and I'll prefer this step by step. So if you hit this button, all the program will be run, and you will see the result at the accumulator. So you cannot tell what happens at each instruction. So I will prefer step by step. So let's hit this step by step and see this section, this purple section, that what changes are happening in here. So I'll just hit step by step. You can see that I have a new menu. It shows go backwards, stop, and go forward. Go backwards means it will go back in the program, and forward means it will go forward in the program. And when I'll hit forward, you can see that accumulator will be loaded with some data. The data is 2 here. We have to load the number 2 in the accumulator. So hit forward. You can see the accumulator has 2 now. Now the next instruction here, it shows the load B register with 03, as we have seen in here, given in here. So MVIB, and now here the accumulator is empty. Now here the register B is empty, but by the time I'll be hitting this forward button, and when this instruction will be executed, you will see the register B will have the data 03. So click forward, and you can see you have the data 03 in here. So the next instruction pointing in here is add B. So when I'll hit the forward button, the accumulator will be added with the register B. So if we add the two numbers 02 and 03, the result will be 05. So you will see that this accumulator will have number 05 instead of 02, because we know the results of the operations, like the logical or arithmetic operations, will go back into the accumulator. So let's hit the forward button, and this add instruction will be was executed, and you can see the accumulator is now loaded with the result 5. And then when I will hit the forward button, it will execute the halt instruction, and the halt instruction means that the program will stop. So the halt is executed, and you can see you have the original menu because the program has stopped now. Okay, so this is the example, simple example. Okay, if I do another program which adds 3 numbers, so I'll go to the editor window and I'll do another instruction, mvi c comma, and then I'll add another number which is like, let's say 04 or just 4. Make sure you have a space between comma and number. And I'll do add b, and then I'll do add c, because I have 2 numbers in the register b and the register c, and the other number will be in the accumulator. So let's again assemble. You should see no error in here, and I'll do step by step. Now you can see accumulator is 00. So run the program. First number is 02, which is loaded. Second number is register B, 03. The third number is in register C, which is 4. And when I hit the forward, you can see the register C is now having this number 04. Then when I will hit forward again, it will add B. So 02, 03 will be 5, which will be back in the accumulator. So we have 5 in the accumulator. Now we have add C instruction. It means C and accumulator will be added. So 5 and 4 will be 9. So the accumulator will have 9 when I hit the forward button. So when I hit the forward, it's 09. So that's the result of 2 additions. And then we have halt, and the program has stopped. So this is how you do a simple program simulation in this 8085 simulator software.